So in this section, we're going to learn about trig functions. We're going to be able to find the values of trig functions on the coordinate plane, find the exact value of trig functions using special triangles in the unit circle, and find the exact value of trig functions at quadrantial angles. So review from last time, remember standard position, where you have the vertex on the origin, the initial side lies on the positive x-axis. Quadrantial angles are angles whose position lies on either the x or y-axis, so they're angles that are on the x or y-axis. Coterminal angles are angles that are multiples of 360 of each other, either plus or minus. So review our special right triangles. Showed this last time. Go through this quick. We have our 30, 60, 90 triangle, our 45, 45, 90 triangle. Remember 30, 60, 90. Across from the 30 is a 1. Then you have 2 as the hypotenuse, and square root of 3 is what's left. 1, 2, square root of 3 with 30, 60, 90. 1 is across from the 30. So across from the smallest angle is the smallest number. 2 is the hypotenuse, and square root of 3 is what's left. That's a 30, 60, 90 triangle. 30 degrees is pi over 6. 60 degrees is pi over 3. A 45, 45, 90 triangle is 1, 1 square root of 2. And 45 degrees is pi over 4. So you're going to have to memorize that. I've seen that in 2 videos now. You're going to hear it again. So here are our 6 trig functions. You've seen them before. Sine, cosine, tangent, secant, cosecant, secant, and cotangent. So we notice here, when we have it on the coordinate plane, we have our sine is opposite over hypotenuse. Well, the opposite is the y value. The hypotenuse is r. And the reason why it's r, when we're thinking about this, kind of like a circle, where if you can make a circle, so r is the radius. So the hypotenuse is called the radius. So we have y, that's my opposite. The radius, or the hypotenuse, is the hypotenuse. So this hypotenuse, that's called the radius. That's why it's an r. So sine is opposite over hypotenuse, y over r. Cosine is adjacent over hypotenuse, so x over r. Tangent is opposite over adjacent, so y over x. And then notice that the cosecant, if you compare cosecant with sine, that the fractions are flipped. That means they are reciprocals of each other. They are reciprocals of each other. So we have cosecant is a reciprocal of sine, secant is a reciprocal of cosine, and cotangent is the reciprocal of tangent. So you just take the fraction and you flip it. So cosecant is r over y, secant is r over x, and cotangent is x over y. So it's just the reciprocal of sine, cosine, and tangent. And when I talk to you, I'm always going to ask you which ones are reciprocal of each other. So what we're going to do on our coordinate plane, we're going to draw our angles just like what we did before, but now we're going to make these reference triangles, because trigonometry is all about triangles. These trig functions are all about triangles. So notice something when we draw the triangles, that in the first quadrant, notice that the x-axis is always part of the triangle. A lot of people mess up the triangle and try to make the y-axis as part of the triangle. The y-axis is never part of the triangle. Always the x-axis is part of the triangle. So you have your x, your y, and then your radius. So notice you have your different triangles. Now, in your triangle, you have what's called, you have your angle, and then you have your reference angle. The reference angle is the angle inside the triangle. It's the angle inside the triangle. So that's what we're going to refer to is that little reference angle. So we have our reference triangle in our quadrants, and inside the reference triangle is the reference angle. The reference angle is always at the origin. It's the angle that's at the origin, not the other angle. It's the angle at the origin. So here's your reciprocal identities. So sine is reciprocal cosecant, cosine is reciprocal secant, tangent is reciprocal cotangent. So those are your reciprocal identities. You need to know these, memorize them. We will be using them now to the end of the semester and beyond. So these are the reciprocal identities. You need to know these. So let's go ahead and find the values of the 6 trig functions when we're given a point at -3, 4. Well, first we're on a coordinate plane. I can plot -3, 4. So that's the first thing we do is plot -3, 4. So there it is. There's -3, 4. And from there, we need to make our triangle, our reference triangle. So here's our reference triangle. So our x value is -3, our y value is -4. So there's our reference triangle. But we need a hypotenuse. We don't know what the hypotenuse is going to be. So to find the hypotenuse, just like any right triangle, you're going to use Pythagorean theorem. So the Pythagorean theorem, to find that radius, well, when you do that, you get a radius of 5. So that is the triangle. Now that you have your triangle, you can do all 6 trig functions. Remember, the reference is always going to be right here. Is the, at the origin. That's the angle that is my theta. That's the angle we're looking at the origin. So when we do the sine, sine is opposite over hypotenuse. Well, my opposite number is -4. My hypotenuse is 5. So sine is -4 over 5. Cosine is adjacent over hypotenuse. Well, my adjacent is the one next to the angle. So next to the angle is the -3. The hypotenuse is 5. So cosine is -3 over 5. Tangent is opposite over adjacent. My opposite is across from my angle. So -4 is my opposite. My adjacent is -3. And a negative over negative is a positive. So you get a positive 4/3 for tangent. Now sine. The reciprocal for sine is cosecant. The reciprocal for sine is cosecant. So what I'm going to do is just take the fraction and flip it upside down. So cosecant is the reciprocal of sine. The reciprocal of cosine is secant, so I take that fraction and I just flip it upside down. And the reciprocal of tangent is cotangent, so I just take that fraction and I flip it upside down. So let's do this one. I want you to try this one on your own. You have an example before to use. Try this one on your own. Now let's go over this. To go over this, we got to plot point 8, 15. So that's in the first quadrant. This graph obviously doesn't go over 8 and up 15, so I'm going to have every line be 2. So there's my 8, 15. I draw my triangle. So there's my triangle. My x value is 8, my y value is 15, but I still need my radius. So once again, I use Pythagorean theorem. When I use my Pythagorean theorem, I get that my hypotenuse is 17. Now that I have my triangle, I can do all 6 trig functions. So sine, and remember, when I'm doing my trig functions, I'm always looking at my reference angle, which is by the origin. This is my reference angle right here. That's my reference angle. It's by the origin. So now, when I'm trying to find the sine, sine is opposite over hypotenuse. Well, opposite my origin is 15. The hypotenuse is 17. So 15 over 17 is sine. Cosine is adjacent. Adjacent means next to. So next to the angle is 8. and my hypotenuse is 17, so cosine is 8 over 17. Tangent is opposite over adjacent, so opposite across from, adjacent is next to, so 15 over 8 is tangent. Now I got to find my reciprocals, my reciprocal functions. So the reciprocal of sine is cosecant, and cosecant, I just flip the fraction. The reciprocal of cosine is secant, so I just flip the fraction. The reciprocal of tangent is cotangent, so I just flip the fraction. Okay, well, this one's a little bit different. This one is not on a quadrant. It's on the x-axis. But I can still make a triangle, but I want to make a pretend triangle. So what I'm going to do is draw a pretend triangle. So here's my triangle. My x value is 1, so that is my horizontal. And my y value is 0. I still use Pythagorean theorem to find my hypotenuse. Well, it's just going to be 1. So there's my pretend triangle. Once you have your triangle, you can find all 6 trig functions. So let's find them. So if we do sine of theta, I get 0 over 1. Well, 0 over any number is 0. If I do cosine, cosine is adjacent over hypotenuse, which is 1 over 1, which is 1. And then tangent is 0 over 1, because it's opposite over adjacent, so it's 0 over in number is 0. And then I can do my reciprocal identities. Well, that's where things get a little bit different. Because if I look, sine, the reciprocal for sine is cosecant, and cosecant is going to be 1 over 0. If I flip the fraction, I get 1 over 0. Well, 1 over 0, well, when 0 is in the denominator, it's undefined. So cosecant is undefined. It's undefined. Well, secant is the reciprocal of cosine, so it's just 1 over 1, which is still 1. Then tangent, the reciprocal of tangent is cotangent, and it is also 1 over 0. It's undefined. So here we notice that some of the functions are not defined on the quadrantial angles because you get 0 in the denominator. And you're going to find that with a lot of the trig functions. And depending on which quadrantial angle depends on which trig function has 0 in the denominator. Then that gives you an undefined function. So let's think about our quadrantial angles. So if I make my quadrantial angles, these are my quadrantial angles. I want you to notice some similarities. First of all, with all my quadrantial angles, 1 is the hypotenuse. 1's the hypotenuse. Okay, so all my quadrantial angles, they look the exact same, and 1 is the hypotenuse. Well, from there, if I'm going to the right, if I'm going in this direction, that gives me a positive 1 as a horizontal, but I go up 0. That's why I make this triangle this way. Going straight up, that means my y value, my vertical is 1, but my horizontal is 0. If I go to the left, that means I'm going horizontal -1, but I'm going up 0. If I'm going straight down, that means my vertical is -1 and I'm going horizontal 0. So those are my quadrantial angles. And you can do that if you don't remember how to draw the triangles. pick a point on that axis, okay? And then from that point, you can put in your x, your y values on the triangle, and then Pythagorean theorem will give you your hypotenuse. You're going to get the same answers either way. So here at 90 degrees, well, 90 degrees is pi over 2. Well, pi over 2 at 90 degrees, that can give me the point 0, 1. Well, once again, going straight up, I need a pretend triangle. So that pretend triangle, if I draw it, so once again, I make my triangle. I'm going straight up. 1 is my y value. 0 is my x value. And the hypotenuse is 1. And I'm always going to use that angle as my reference. So from there, here we go. We have sine is opposite over hypotenuse, so that's 1 over 1, which is 1. Cosine is adjacent over hypotenuse, which is 0 over 1, which is 0. And tangent, well, if I do tangent, tangent is opposite over adjacent, so 1 over 0, so that's undefined. It's undefined. Then let's do the reciprocals. Well, the reciprocal of sine is cosecant, and cosecant is 1 over 1, so it's 1. The reciprocal of cosine is secant, but secant is 1 over 0, which is also undefined. And then the reciprocal of cotangent, well, if I flip cotangent, I get 0 over 1, which is 0. So cotangent is actually defined. So I want you to try 3 pi over 2. Okay, let's go over this. So first of all, 3 pi over 2, that's going straight down. That's 270 degrees. So I need to make my pretend triangle. So my pretend triangle, I'm going straight down. So my vertical is -1. My horizontal is 0. My hypotenuse is 1. So there's my pretend triangle. From there, I can do all 6 trig functions. So sine is opposite over hypotenuse, so -1 over 1, which is -1. Cosine is adjacent over hypotenuse, 0 over 1, which is 0. Tangent, well here tangent is opposite over adjacent. I have 0 in the denominator, so that's undefined. So the reciprocal of sine is cosecant, so 1 over -1 is still -1. The reciprocal of cosine is secant. So that gives me 1 over 0 again, which is undefined. And then we have the reciprocal cotangent. Well, 0 over -1 is still 0. So there's your 6 trig functions. Okay, the unit circle. The unit circle is where the radius is 1. Well, if I combine that with all my special triangles, I get this little unit circle that you see. This unit circle is very helpful in solving your trig functions. You can memorize this unit circle to help you find trig functions at these special angles. You're going to be using the trig functions at these special angles over and over again. In your algebra 2 trig class, you probably learn the unit circle and learn those values. If you can do these trig functions using the unit circle, wonderful. I'm going to teach you a little bit different way, but the unit circle still works. To show your work, all you got to do is show the point that you use for the unit circle. So remember in radian, this was in the last video, but I want to reiterate it. In radian measure, if you have pi over some number, you're in the first quadrant. If you have one less than denominator, you have it in the second quadrant. When you have one more than the denominator, you're in the third quadrant. And then one less than double the denominator is in the fourth quadrant. So that's how you can tell in radian measure what quadrant you're in. And of course, if you have an angle that is more than 2 pi, you got to find the coterminal angle and then find out what quadrant you're in. And remember, to find a coterminal, you either add or subtract 2 pi to find the coterminal angle. Okay, here it says we have a unit circle. Well, if we have a unit circle, once again, that's where our radius is 1. So let's go ahead and plot this point. We know we're in the second quadrant, and my x value is -1/2, and my y value is square root of 3 over 2. Yes, I know that's not to scale, but we know we're in the second quadrant. And then we got to find the radius. Well, it's a unit circle, so we know that my radius is going to equal to 1. But once again, I have my triangle. Once you have your triangle, you can do all 6 trig functions. So once again, we are using this as the reference angle. So that angle that's by the origin is the reference angle. So sine is opposite over hypotenuse. So square root of 3 over 2 is the opposite, but 1 is the hypotenuse. Well, anything over 1 is itself. So that's square root of 3 over 2. So notice that sine, when you have the unit circle, sine is always the y value. When you're in a unit circle, sine is always the y value. You might want to write that down. Sine is the y value in the unit circle. Cosine is adjacent over hypotenuse. So it's -1/2, and the hypotenuse is 1. So -1/2 over 1. Anything over 1 is itself. So cosine is -1/2. Notice with the unit circle, cosine is the x value. So put that in your notes. With a unit circle, cosine is the x value. Then tangent. Tangent is opposite over adjacent. When you divide by a fraction, remember you multiply by the reciprocal, and then you'll get square root of 3 over -1, which is negative square root of 3. So now that you know sine, cosine, and tangent, then the reciprocal functions, the reciprocal of sine is cosecant. So what I do is I flip the fraction. But when I flip the fraction, I get a radical in the denominator. I can't have radicals in the denominator, so I have to rationalize the denominator. So I multiply square root of 3 to the top and the bottom, and you get 2 square root of 3 over 3. For cosine, the reciprocal of cosine is secant. So flip the fraction, that gives me -2, because -2 over 1 is just -2. And then for tangent, I flip the fraction for cotangent. So cotangent, I get -1 over square root of 3. Remember, any whole number can be written over 1. So if I flip it, I get -1 over square root of 3. I can't have a radical in the denominator, so I rationalize the denominator. So it gives me negative square root of 3 over 3. And no, I cannot reduce that because that's 3's under the square root. It is not like the 3 on the outside the square root. So let's find the exact value of sine of 5 pi over 6. So 5 pi over 6, that is 1 less than the denominator. So that means I'm in the second quadrant. So there's my angle in the second quadrant, 5 pi over 6. So that's my reference triangle. So I make my reference triangle in the second quadrant. So that's 5 pi over 6. What is my reference angle? Well, my reference angle is, the way to find the reference angle in radian is real easy. It's just going to be pi over the denominator. So pi over 6 is my reference angle. Well, pi over 6 is actually 30 degrees. So I have a 30, 60, 90 triangle. So remember, across from 30 is 1. Across from the smallest angle is the smallest number, 1. Then my hypotenuse is going to be 2. And what's left is square root of 3. But since I'm in the second quadrant, it's going to be negative. So there's my triangle. Once I have my triangle, I can find all 6 trig functions. But I don't need to find all 6 trig functions. I just need to find sine. And sine is going to equal to, opposite over hypotenuse, which is 1/2. You could also do this with the unit circle approach. You would have noticed that the y value would have been positive 1/2 in the unit circle approach. Okay, secant of 7 pi over 4. Well, 7 pi over 4 is 1 less than double the denominator. So therefore, I'm in quadrant 4. So since I'm in quadrant 4, there's 7 pi over 4. My reference angle, it's just going to be pi over the denominator. So it's going to be pi over 4. That's my reference angle inside the triangle. So pi over 4 is 45 degrees. So a 45-degree triangle is 1, 1, square root of 2. So 1 and 1 are the legs, and square root of 2 is the hypotenuse. But remember, my y value is negative because I'm in the fourth quadrant, and square root of 2 is my hypotenuse. Now that I have my triangle, I can do all 6, but I don't need to do all 6. I got to do secant. Well, secant is the reciprocal of cosine, and cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So it's going to be equal to, hypotenuse is square root of 2. Adjacent is 1, so it's going to be just square root of 2. So that's secant. Tangent of 4 pi over 3. First, we got to graph 4 pi over 3. Well, 4 pi over 3 is 1 more than the denominator. So 1 more than the denominator is in the third quadrant. So I draw a triangle in the third quadrant. So there's 4 pi over 3. My reference angle is just going to be pi over 3. Remember, all you do is take away the 4, so it's going to be pi over the denominator. Pi over 3 is 60 degrees. So I have a 30, 60, 90 triangle. Well, across from the 30 is 1. So if we have 60, 30 is the other angle, so across from it is 1. But we're in the third quadrant, so it's going to be negative 1. Then the hypotenuse is 2, and what we have left is square root of 3. And it's going to be negative because we're in the third quadrant. So now I have my triangle. Now all I have to do is find tangent. Well, tangent is opposite over adjacent. So opposite is negative square root of 3, and adjacent is negative 1. Well, a negative over a negative is a positive, and anything over 1 is itself. So it's going to be just square root of 3. Negative 5 pi over 4. Well, we only figured out how to do the radian measure with positive angles, but I can find the coterminal angle. So let's do that. So to find the coterminal angle, I need to add or subtract 2 pi. So 2 pi is 360. So 2 pi, I need to add to negative 5 pi over 4. Well, 2 pi with a denominator of 4 is 8 pi over 4. So 8 pi over 4 is 2 pi. So I'm going to add that. So negative 5 pi over 4 plus 8 pi over 4 is 3 pi over 4. So let's graph 3 pi over 4. Well, 3 pi over 4 is 1 less than the denominator, so I'm in the second quadrant. So that is 3 pi over 4. And remember, 3 pi over 4 is coterminal to negative 5 pi over 4. It's the same angle. Okay, so it's just coterminal. So my reference angle is just pi over 4. Remember, it's just pi over the denominator. That's my reference angle. Pi over 4 is actually 45 degrees. So 45-degree triangle is 1 square root of 2. So let's put those values in there. So 1 square root of 2. But remember, my x value is negative because I'm in the second quadrant. And now I can do all 6, but I don't need to do all 6. I just need cosine. So cosine is adjacent over hypotenuse. So it's going to be negative 1 over square root of 2. I got to rationalize the denominator, so I multiply square root of 2 to the top and the bottom. So that gives me negative square root of 2 over 2. Seven pi over 6. Well, 7 pi over 6 is 1 more than the denominator, so I'm in the third quadrant. So if I'm in the third quadrant, 7 pi over 6, my reference angle is going to be pi over 6. Well, pi over 6 is actually 30 degrees. So I have my 30, 60, 90 triangle. So across from the 30 degree angle is 1. And remember, we're in the third quadrant, so it's going to be negative. Then I have 2 is the hypotenuse, and square root of 3 is what is left. But it's going to be negative because, once again, I'm in the third quadrant. So now I have my triangle. I got to find cotangent. Well, cotangent is a reciprocal of tangent, and tangent is opposite over adjacent. So cotangent is adjacent over opposite. So adjacent over opposite is negative square root of 3 over negative 1. A negative over negative is a positive, and anything over 1 is itself. So it's just going to be square root of 3 for cotangent. Now, if you have special angles, wonderful, we can find those exact. But if you don't have special angles, your calculator, you can use your calculator. So here are some non-special angles that we're going to use our calculator for. So cosine of 48 degrees, on your calculator, you see the cosine button. Make sure you're in degree mode. I can show you that on your calculator in class, but make sure you're in degree mode and press cosine, then 48, and you'll get 0.669 and so forth. That is your decimal approximation. Cosecant. Well, there is no cosecant button on your calculator, but we do know that cosecant is 1 over sine. So that's how I put it in the calculator. 1 divided by sine of 21 degrees. Now letter C is in radian mode. So make sure you're in radian mode when doing letter C. So you go to mode, highlight the radian, and then you're ready to do this. Hit the tangent button, hit the pi button divided by 12, put that in your calculator, and there's your answer for tangent of pi over 12.